Hey, so we are back in the terrain map, which is a map I made a year or so ago, based on a question from a developer using the toolkit who wanted to add, different movement costs for different kinds of terrain. And the reason I'm back is because I got another question about how to modify terrain and other things from another developer, which was close enough to this that I thought it would make the most sense to build upon what I had already made. So here is where we were at the end of the video I made a year ago, or roughly. I had to remake this. And the new question I'm trying to answer here is asked by Augmented Smurf in the discussion in the support thread, who's asking, so he wants to make it sort of game, and he wants to make it so that when you walk into water, their movement is terminated. This means that if they have to move through 3 tiles to cross a river, they have to take 3 turns, as every tile of water stops their movement. I'm wondering if there is a way to make a tile behave in this way. So maybe you'd think you could just use the sort of terrain cost we have here, but you can't really, because if you were to add like an infinitely high movement cost, you would never be allowed to enter the tile either. So we need to make it so that the water doesn't care how much movement you have left when you're entering it, but it cares. But after that, you can't move out of it until the next turn. That's the idea. And this is just one of the things I'm going to try to do here, because Augmented Smurf had other questions. So they wanted to make it so that when you move to a higher up tile, it's going to cost more movement, and that's something we have by default in the toolkit. You can do that by changing the height slow increment, but they wanted movement to just cost 1 when you're moving down, regardless of how far you are moving down. So that's the second thing we're going to do. And then there's the third thing that was asked, and that is that if your unit is starting on a road tile, then you want them to have 3 more movement than if they started on any other type of tile. So we have 3 different things then. So it's movement into water, but you can't move out of it the same turn. You have height differences in costs, but only when you go from lower to higher elevation, and you have increased movement when you start on a road tile. So we'll do each of these in turn. So you need to have watched the previous terrain tutorial to figure out what I'm doing here. But I guess we're starting with the water. So at the moment, water works as in, or from the previous tutorial, you have that within each unit you can define, let's search for terrain, the costs of entering terrain. 0 means that it costs the same as usual. Anything added to that means that it costs more movement. If the unit does not have the type of terrain in this map, that means that they can't enter it. So we see that for this unit it costs 2 to enter, or this guy can only move in water because that's the only terrain that's defined here, can't move out of this puddle. And this other guy can move into water, but it costs a lot of movement, so he prefers moving around it. And forest costs more than dirt, etc. So that's our starting point. We want water to behave differently for this. So we have our pathfinding type that we made the last time. So we can modify this. And so this is where we were at adding tile if valid. So for this we are checking then on the grid terrain. Do we have any special terrain? If not, we just run pathfinding as usual. If so, then we add the extra movement cost. But we want to do more here. If it is water, we don't want to add this to the list of tiles that we want to keep searching from. And to do this, we will need to modify other parts of this add tile if valid function. We can't just throw this stuff at the start of the function because we're going to have to go a bit deeper. But we can enter this BP path, and just copy the code we have here. And this is what we want to modify. We can still make it so that if we don't find terrain on the tile we're trying to enter, we're just doing the regular pathfinding like we always did. But now we have to do some some slightly more complex stuff for to make sure that we have this special rule for entering water, or rather exiting water. So then we check, okay, so in this terrain, does this tile have terrain defined? Yes. If it does, let's find the costs of this, and we are adding this, but we want to keep going further on here. We're still doing it so that if we don't find this in terrain cost, we are not adding this tile at all, so we'll keep this. But now we are checking then here if the cost of entering this tile is more expensive than our movement. We can check this in the parent function here. This is what we're checking. We're checking the total cost. Is it lower or equal to than the move of the unit that we're using here? And if so, we continue, and you will see that we're using total cost a couple of more times here as well. So in this older function, we were just adding these together, and we passed it into this parent function, and then we could use that as a local variable within this function. But we can't do that now. We don't have that local variable automatically generated in this part, so we will need to make our own. So I'll promote this, and I'll call this then local total cost. So we're setting this here. So the layout of the blueprint I'm not going to care too much about here, so it won't look too that pretty, but I'll at least make it readable. And now we're checking, okay, so our local total cost, is that lower or equal to the move, which is a local variable we have from the function here. So we can keep that. And then we do much the same as we would otherwise. We are adding this new tile to the paths, so the various tiles that we can move to. Then we are checking, are there any units here on this tile? And this is where I do something similar that what we want to do here, because if there are no units, usually in pathfinding, then we will add this new tile to the open list of tiles, and this is the list of tiles to be considered for further pathfinding. So what I'm doing here is that if there is a unit on a tile that we're trying to enter, then we do add that to the tiles that we can reach, but we don't add it to the list of tiles that we want to keep searching our pathfindings from. And it's the same thing basically we want to do with our water terrain. So as I've said in the previous video, this is like a function that gets called a lot of times during pathfinding. So we want to make it as cheap as we possibly can, and the find node is somewhat expensive, so therefore we will want to store this so we don't have to call it twice, because we want to do the same thing here. I can first do it in the find way, so maybe it's clear what we're doing. So that's the edge index. So if there is no unit on this tile, then we will check, okay, is the terrain of this tile water? And if it is not, then we want to add this tile to the tile list. But if there is water, then we don't want to continue pathfinding from this tile. So this should be enough to get it working. But I kind of don't want to do a find twice here. So at this point, so therefore I'll promote this to, let's see, local terrain. Here. I'll use this here, and I'll also use the local terrain over here. So, oops, I mean there. So then we don't need to use a find node twice within pathfinding, so it should be slightly cheaper. Now this should be enough to get things working. So yeah, let's delete this boat unit here, and we'll just keep this guy. I'll just set water to 0 movement, so it functions as regular So it costs 1 then, which is the default movement cost on moving between tiles. And I'll, just so we don't have this forest messing up, I'll add some tiles here, and we should see now that we can enter these, but we can't move through them. We can move into them from the other side. We can make it clearer by doing it like so. And we can see that we can move into all of these, but we can't move through this water. We can move past it. If we move into the water and then end movement, then we can move out of it. But we can just move one tile into the one that's next to us. So this works like a moat in Heroes of Might and Magic, and it works the way I believe Augmented Smurf is describing what he wants. Okay, so that was the first of 3 questions, and now let's move to the next. We can do the height thing, but let's do the road thing first instead, since we can keep that within our pathfinding. We need to do something in the grid manager for the height different thing to work. So let's start with the road. I'm just going to use dirt for this. I'm just going to say that this is our road. I'm not going to bother adding new terrain types for this example. So how do we want this to work? For dirt, first let's see. Yeah, so dirt is the regular movement cost, and we want to add 3 to our movement if we are starting on the dirt or starting on the road. So we can again go into the path, and then we can go at the start of run pathfinding here, and we can do this fairly simply by checking our grid manager. We're finding our grid terrain, and then we want to set the move range to something higher if we are starting on dirt. So again, I'm going to use a local variable for this, and then I will set this. Let's see, so we will find something here. We'll find at the start index, so the index that we're starting pathfinding from, and we will check, is this equal to dirt? And then let's make a bit more space. Yeah, we can actually use like a select node for this. Let's rename this, by the way, so local move range. And we will set this local move range to, then we will select an integer. And if we are on dirt, then we want our move range to be set to our move range plus 3. Like magic number here, that's okay for the example. If not, then we want to set it to the regular move range. And we want to set this here and use the local move range for our move range there. Okay, so now if we hit play, so we're moving. It's difficult to see between the blue sheen here, so you would want to make probably a different grid UI to see this more clearly, but let's decrease the movement, and actually let's change the grid UI, why not? Some bonus. Grid UI, what grid UI are we using? Grid UI hex. Let's just alter this directly instead of making a new one. And for the move marker, what do we use? What do we have? We can just use the current frame. Maybe it will look a bit weird. Let's see. Yeah, okay. So at least you can see the colors more clearly. So these are our roads or our dirt. So let's decrease the movement of this guy to again make it a bit clearer. I'll put it down to 3. There, so we can move 3. Now why can we move so far? Ah, that's because everything counts as dirt, right? That's how I set it up. Oh yeah, that's because in our pathfinding here we are checking the local terrain, and the default value for the local terrain is dirt. So yeah, I'll just set this to forest. We would probably want to do this, have dirt be something that has no special rules, and then create a separate road terrain for this. But for the example, we're starting like this. So yeah, we're moving 3 tiles. If we're moving onto our dirt and then we end our turn, now we can move more, I would suspect. It's still 3. That's odd. And that's of course because now he counts all the default tiles as forest. Yeah, so let's actually do this properly, right? I should have done that from the start. Let's just add road to our terrain types, and then on our unit here, we'll modify BP unit for this directly. I think we could do that straight on the unit as well. So we'll have this to 0. We'll set road to 0, and then dirt to 0. There. And now in our terrain path, we will set the local terrain default to dirt, and in run pathfinding we will check if we are on the road. And on our tiles we will want to make a new terrain type. So for road we'll change a different color. What do we have? Okay, let's use then black. And for these tiles we will make these roads, and now they're black. It's not a huge visual difference. Now it should work. Okay, so we have a movement of 3. We're moving on to our roads. We're ending movement, and now we have a movement of 6. But yeah, as I expected, we can't actually move to these. We will need to change the ability that we're using for that, because the default move attack ability, it actually checks the move cost that you're moving to see if you're allowed to move there. And the move cost is still higher than the move value of this guy, even though we're using now a higher value during our pathfinding. But we can change that pretty quickly in this, in the serve interact. We're checking, is the tile in move range for this ability. Normally we are checking, is it within the possible move, and is it in our stored paths map. We can just check, is it contained in our path map. And that should be enough. Let's see. Yeah, now we can move 6 tiles. Okay, so that was the second question. We have 1 remaining. Now I'm blasting through these pretty quickly, but when you have a small kid and limited time to make tutorial videos, you need to try to be quick. Okay, so the last thing is that we want to have height differences. So we want movement cost differences from moving to higher tiles. And so for that we want to set it up so that we can easily have some new tiles we can move on top of. So let's do that. We'll make a new grid actor for creating platforms with height differences that can snap to our hexagonal grid. I'll create a grid object for that. Main grid actor, which we use to have the grid snapping functionality. I'll call this BPGA hex platform. Just close the other tabs here. And I'll add a static mesh. So this will be a platform that we will be able to move on top of. I'm going to use my hexagonal wall mesh for this. There we are. No, that's not the correct one. I want the hexagonal wall there. And I'll change this to a different color so we can tell it from our walls. And then for blocking, I'm going to set this to custom. I don't want to block range trace with these, or maybe I do want to. I'll keep that. And path trace not by default, and I'll show why. Or maybe I'll keep it on, and I'll show what happens. And I'll add this to the grid anchor. So now we have this tile that you can drag around here, but you can see that something's wrong with grid snapping, and the reason is because it is colliding with itself. It's trying to find the ground and place itself on the ground, and it uses the path trace collision channel for that, and then it collides with itself. And for traces you can normally check a box to like ignore self, but we are actually using a tracing function within the grid manager here, so we can't just check that box. So we need to make it so that this does not collide with itself, and we still want it to block path trace because that's needed for this the top of this tile to be added to our grid locations at runtime. But we can fix this in our construction script by taking the static mesh and let's see, collision, what's it called here? So we want to set collision response to a specific channel, to then path trace to ignore, and then we run the construction script of the grid actor, which does the tracing functionality, and then afterwards we want to set it back to block. And now we can place it around like this. And yeah, we will need to set up our grid manager to enable height differences. So let's see, search for height. We're setting height map to 1 level for this, and we'll just pre-generate the gameplay grids so we can see the tile indices. And now we see that it has been added to our grid. So we can't move up on top of this because it's too high up at the moment. Augmented Smurf wanted to set it up so that we can move as high as you want. It just increases the cost of moving there. So let's find the height settings in our grid manager. So we can say height impassable cutoff. How high up does something have to be before we're not allowed to move there? And we can increase this by a lot. Let's say 500. And now we should be able to move up here. No, we are not. Let's see. I guess we need to change the height between. Oh no, I guess it's the height slower increment that does this. Yeah, because we're not using multi-level grids. Now we can move on top of this. So what the height slow increment is doing is that it checks for every increment of this size in height differences between tiles, add 1 to the movement cost. So at the moment I'm having that at 500. That means that it does nothing. So the movement is always going to be 1 because we are not increasing the movement cost all the way up to the cutoff. If I change this to 100, and then we can show this if I want to show the edge costs, debug display tile edges, you need to have pre-generate enabled to see this. And now we can see that the movement cost of moving up here is 3. The movement cost of moving down is also 3. So let's add another of these, by the way, on the side so we can see some differences here. I'll just make this smaller, and then I'll just check anything really to make the construction script run again on the grid manager. So now we see that it's updated. We have a movement cost of 2 up here, 2 here, or 3 if you want to move directly up. So this is still default toolkit behavior at this point. So we need to change how the grid manager assigns these movement cost differences based on height. So we can go into our grid manager. We'll need to modify the base grid manager for this. Let's see. Yeah, what was this? Oh, I guess this was from the last video, a debug printing that we did just to check if we have any type of terrain. I'll just keep that in. So the edge costs, the default edge costs are set up in setup grid arrays here in the grid manager, and then let's see, generate grid edges, and then we want to set the edges based on terrain. That's the relevant bit for us here. And at the moment we are using 1 level for our height maps. So we can change this add tile edges 1 level height map. It's not going to matter, I think, because the same function that we're going to modify is going to be in both this and the multi-level one. Because where are we finding the edge cost? That's this one. Get edge cost from Z difference, so the height difference between tiles. And here we can see how it usually works is that it checks, is the absolute difference between these the two tiles, the parent tile and the child tile, is it greater or is it lower than the height slow increment? If it is, then we just return a cost of 1. If it is not, then we will if it's lower than the height impassable cutoff, then we want to return a cost of 0, that we can't move there. And if it is somewhere in between, then we want to set the cost based on this height-slope increment, or the height difference divided by the height-slope increment. That's the cost that we're setting. And you can see here that I'm checking the absolute value between the tiles. So because we're going to change the movement cost if we're moving up or we're moving down. But in this game, we don't want to use the absolute actually to check this. So I can just remove this absolute part here. We can keep it for the other ones. That shouldn't really matter. Or to make sure that we are using a positive value when we are assigning the costs. That might not be necessary, but that's something I would have to check. But now if we are using the absolute here, we can see, so it's actually the opposite of what we want now. So we have a higher movement costs to move down, but not up. So we will have to switch that around, like so. And now it looks correct. So let's see if I can omit using the absolute value at all here. As long as this is always positive, would it be always positive? Let's see. Yeah, my daughter will be returning from the in-laws any minute now, so no time for calculating that. But so now we have it working the way we want. So we have higher movement costs for moving up, but not for moving down. We can check this. So we are not able to reach this with our movement. We can reach this, and we can reach this now, but when we're moving down, there's no problem on moving the same range. So I believe that answers all the questions, I hope. So Augmented Smurf, if there was something that was different from what he wanted here, of course, let's just continue the discussion either on Discord or the support thread for anyone else watching this video who have any questions of how to set this up or similar things or anything that's confusing. I imagine there might be, since I went pretty fast this, then you as well. Feel free to ask me questions about it. Discord support thread or this YouTube video. If it's specifically about this video, then that's fine as well. And I hope it was useful. We got to touch on a lot of different things without going into depth, but maybe that might be a useful way to set up some videos as well. So okay, that's it for now. See you in another video.